ahead to the next module of electrons and photons. And in this module, we are going to learn about what is the effect of frequency on stopping potential. Now students, in this module, we are not going to study graph. But mind you students, this is that module which is going to build your base towards the concept. And in this module, what we first consider is a metal plate, certain free electrons and light, which is giving the energy to this free electrons. We know that if this light is having its frequency which is increased, if the frequency goes on increasing, then the energy of the photon also goes on increasing, because we know that E is equal to h nu, and if the nu increases, then E has to increase. And we know E is equal to h nu when h is constant, so if nu increases, the E will also increase. We know that the energy of photon increases, then the kinetic energy also increases. Now you will ask me, sir, why the kinetic energy should increase? You can see E is equal to W naught plus Ke max. All the energy of the photon is utilized in two things. First, to make the electron come out of the surface, that is in the terms of work function. And second, if the energy is still remaining, that energy will be used in the form of kinetic energy maximum. And we know that if the energy of photon is increased, certain amount will be used for work function, and the amount which will be used for work function will be always constant, because work function is constant for some amount of material. Now if work function is constant, so I know that if the energy of photon increases, definitely the kinetic energy will also go on increasing. Now I know if the kinetic energy of the electron increases, the work done to stop the electron should also increase. So it is not only that kinetic energy is only increasing, it is also the work done to stop the electron should also increase. If kinetic energy increases, then work done to stop it increases. And if work done to stop it increases, then we know that work done is equal to E into Vs, where Vs stands for stopping potential and E stands for charge of a single electron. We know that charge of a single electron is constant, so if work done to stop the electron will increase, then the stopping potential should also increase. So we conclude that if the frequency of the incident radiation goes on increasing, then the energy of photon also goes on increasing. If the energy of photon also goes on increasing, we know that the kinetic energy of electron also goes on increasing. We know that if the frequency increases, the kinetic energy also increases, and we also know that the energy of photon also increases. So Ke max also goes on increasing. And if the kinetic energy of the electron goes on increasing, you can see if the kinetic energy goes on increasing, then the work done to stop it should also increase. So I can say that if the kinetic energy is increasing, then the work done to stop it should also increase. And if the work done to stop it increases, then the stopping potential also goes on increasing. So in short, I would revise it all. If the frequency of the incident radiation increases, then the energy of the photon increases. If the energy of the photon increases, then the kinetic energy maximum also increases of the electron. If the kinetic energy of the electron increases, then work done to stop the kinetic energy should also increase. And if the work done increases, then the stopping potential should also go on increasing. So what do we finally conclude? We finally conclude that frequency is directly proportional to kinetic energy maximum. How? We can see from the above result. We can see if the frequency increases, energy of photon increases, and hence kinetic energy of electron also goes on increasing. So can I say frequency is directly proportional to kinetic energy maximum? Also, we can say that frequency is directly proportional to stopping potential, because we know that frequency results in the increase of kinetic energy, and hence we require more work done, and hence we require more stopping potential. So students, with the help of this module, we conclude that frequency is directly proportional to stopping potential as well as kinetic energy maximum. Thank you.